Opportunities don't happen, you create them. So, hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW Gulf. Today, students, I welcome you all to your ultimate recap for the chapter Structure of Atom under our batch, Achievers Batch. So, I guess, students, you all have finished this particular chapter, and now it's time for your revision. So what are we going to do, ma'am? We are going to revise each and every topic with regard to this particular chapter, and we are going to end this up so that after this you can practice a lot of questions. Yes, everybody, I feel many of you may have made already the notes section, right? But some of you have not yet made any kind of notes. So no need to worry. You can create your short notes with the help of this particular session, because we are going to start from the very basic concept of electron, protons and neutrons, and then we are going to cover the complete chapter till the end, till electronic configuration. So no need to worry if you have not, heard a single word with regard to this chapter. Let me tell you, students, we are going to cover from the very start. Yes, everyone. Now, I'm not only going to tell you what are the, topics we are going to cover in this particular session, but I'm also going to tell you with regard to the important key topics that are required for your examination. For example, if you're going to scroll up the previous year question papers, you might observe that there are some particular topics from which questions are repeatedly asked, right? So I'm going to tell you that topics as well, that yes, you have to cover this topic for your examination. Don't miss this topic. So by this way, we are going to cover this particular session, students. I hope so you all are ready. Now, you can take up your notebook, take a water bottle and a pen and start this session with a beautiful smile. So, how we are going to proceed it? Let me tell you what is the today's target, students. So, basically, our today's target is, first of all, we are going to do the introduction section, where we are going to understand about an atom, okay, about the construction of an atom. That means that we basically have an idea from chapter first, that is some basic concepts of chemistry, that atom is an indivisible particle, but it is divisible. It has been further divided into three fundamental particles, that is electron, protons and neutrons. So we will be first of all understanding about them. After that, students, we are going to understand in depth about discovery of the subatomic particles, the atomic models. Then comes atomic number and mass number. See, atomic number and mass number is I would say, a start towards the introduction of elements. Okay, so from where you are going to understand about how an element is represented. Okay, you may have observed the periodic table that you do have at your homes, right? So how you have to write a particular element, where you have to write the atomic number, where you have to write its mass number. So all the representation techniques we are going to understand in the atomic number and the mass number topic. And then we are going to understand what are isotones, isoelectronics, isobars, isodiaphers, isosters, all of these, right? After the, students, we shall be covering about the wave nature and the particle nature. Okay, both of these nature we are going to understand in depth. We shall be understanding with regard to wave, what is wavelength, what is amplitude, what is frequency, what is velocity. So all of these terms will be cleared under the topic wave nature and the particle nature. Then comes photoelectric effect, and after that we have Heisenberg uncertainty principle. Moving on to the next topic, we have Schrodinger wave equation. And then we have nodes and antinodes, very, very interesting topics we are going to cover, students. Then we have orbitals and shapes, and at last we shall be covering about quantum numbers and electronic configuration. So this is going to be the target for our today's session, how we are going to proceed. This is basically the sequence of our today's session. So starting with my very first topic, before moving on to my very first topic, the introduction session, let me tell you, students, topic wise importance of this particular chapter. If I talk about topic wise importance, so you should know that from the previous yearly asked question papers, I have just taken a scenario that there were some topics from whom questions were repeatedly asked. So what are that topic? Now you will say, ma'am, are you going to only make us understand that major topics, or you're going to cover the complete chapter? Let me tell you, I'm going to cover the complete chapter. But yes, you should know at least that these topics are repeatedly asked, so you can revise it, in depth. Okay guys, and you can practice more questions based upon them. So what are those topics? Let us see them as well. So if I'll talk about those topics, the very first topic that we have to know is about the subatomic particle, guys. After this, the questions are asked from the electromagnetic theory and the photoelectric effect. Then questions are generally asked from Bohr's model for hydrogen atom, and at last, the maximum questions, if you're going to observe, is from quantum mechanical model that is quantum numbers. Okay. So basically, these are the four topics from which maximum amount of questions are asked from this particular chapter, students. Now, let us start with the introduction session. In the introduction session, as I've already told you, we have started in class 11th, first chapter, some basic concepts of chemistry, that atom is an indivisible particle when we were understanding with regard to Dalton's atomic theory. But let me tell you, students, atom is further divided. It is further divided into three fundamental particles. Guys, what is basically a fundamental particles? Okay, what are fundamental particles? So let me tell you. Electrons, protons and neutrons basically are your fundamental particles. Electron is represented by E, has a power negative, because electron basically, students, is a negatively charged species. And then we have proton represented as P, and then we have neutron represented as N. Okay, students. So basically, these are our fundamental particles. The thing that we should know with regard to them, I will let you know their discovery, how they were discovered. But yes, you have to learn the charge and mass of an electron as well as proton as well as neutron. Let me tell you, if I'll talk about the charges of electron and proton, the values are same, just the sign is different. Okay. So if you're going to observe for electron, the charge is minus 1.6 into 10 raised to the power minus 19. So over here you can clearly observe it is negative sign written over here, and it is a positive sign for the protons. Because electrons are negatively charged species, protons are positively charged species, while neutrons are neutral in nature, guys. Okay, so it has no charge on it. Now let us understand about them. Okay, as I'm saying that electron, protons and neutrons are fundamental particles. So guys, how they were discovered? Okay, let us move from the very basic key concept, that how the discovery of these fundamental particles started. So the very first is discovery of electron. Now how you started the discovery of electron? By study of cathode rays. By which, ma'am? By study of cathode rays. So when you understand about cathode rays, you automatically got to know about an electron. Similarly, the discovery of proton was explained by the study of anode rays, guys. Okay. So if I'll talk about the discovery of electrons, that is study of cathode rays, here an experiment was performed, that was the William Crookes discharge tube experiment. What was the experiment, students? It was William Crookes discharge tube experiment. Now what actually happened in this particular experiment? Why I have written William Crookes discharge tube experiment? Because William Crookes, scientist, was there who performed this experiment, the study of cathode rays. He took a Crookes tube. What he did? He took a Crookes tube. So when he took Crookes tube, okay, there was cathode, there was anode. He just applied high pressure. Sorry, he applied high voltage, not high pressure, high voltage, and low pressure was maintained. Let me explain you the complete experiment. Okay, how it happened. So see, basically this was the Crookes tube in which the experiment was performed. Okay, we have cathode on one end and anode on the another end. Okay, now what happens here? We took a gas, okay, inside it. Now this gas is at 1 atm pressure. In the very first case, it is present at 1 atm pressure, and over here high voltage is applied. High voltage is applied. So students, when a high voltage was applied in this Crookes experiment, basically in the very first case, when the pressure was 1 atm, high voltage was applied, it was observed that no current flows. No current flows. Now the second observation. Now the pressure is reduced. What happened to the pressure? Pressure is reduced. Now the gas is at 1 mm pressure. When the pressure was reduced, it was observed that there were some rays that was traveling from one end towards the another end. As you can clearly see that the rays are traveling like this. From anode, sorry, from cathode, some rays are traveling, okay, some rays are traveling. So this happened when the pressure was reduced. When the pressure was reduced, current started flowing. Current started flowing. Now talking about the third case, now the pressure is almost reduced at 0.01 mm pressure. Now at this point of time, we inserted a perforated anode. Why we inserted a perforated anode? Because see, in the second case, when the pressure was reduced and high voltage was applied, some rays were traveling. Now the rays was not visible to us. To make it visible, we inserted a perforated anode. Ma'am, what do you refer to as perforated anode? The anode which has holes in it. Okay, and we saw that a greenish glow was observed when the rays were moving from cathode towards anode. Okay, these cathode rays were traveling with so much speed that they were not visible to us. Invisible to us. So what we did is we just kept a perforated anode, and the rays traveled from one end towards the another end, and when it hit the surface, it produced a greenish glow over here. So over here, greenish glow was seen. And then when they studied about them, the properties of cathode rays, they got to know that it is basically the discovery of electrons. So this was the Wilhelm discharge tube experiment, everybody. You can note it down in your books as well. You can mark in your copies as well. Clear, everyone? Now, what were the properties of cathode rays? So the very first property is that they produce a sharp shadow of the solid object placed in their path. I will show you a diagram over here. For example, if we have kept an object, it will produce its shadow. What it explains us? That they are traveling in straight line. That's why only it is producing a shadow, right guys? So this is the very first property of cathode rays, that they produce a sharp shadow of the solid object placed in their path. This shows that cathode ray travels in straight line. Clear, everyone? Now, okay, let me show the diagram. First of all, you can clearly see, for example, if we have this object, cathode rays, as you know, will travel in this direction. So, it will produce a shadow over here. So, that means cathode ray travels in straight line. Very important line, cathode ray travels in straight line. Clear, everybody? Now, the next part. If a light pedal wheel, if we have this light pedal wheel over here, okay, which we have mounted on an axle, is placed in their path, in the path of cathode rays, guys. Okay, what will happen? The wheel will begin to rotate itself. This also explains us that cathode rays are made up of what? Cathode rays are made up of material particles. So now I guess you know the basic two properties of cathode rays, everybody. The first one is they travel in straight line. The second one is they are made up of material particles, which are proved through the experiments which I have shown you over here. Everybody please write it down. Done? Okay, students. Now the next property about this is that cathode rays carry negative charge, due to which we compare it to electron. Now see, when an electric field is applied on the cathode rays, if you are applying electric field, okay, they are deflected towards the positive plate of the electric field. Always remember, positive and negative will attract each other. Positive and positive will repel each other. Negative and negative will repel each other. So what it is saying is that when we have applied an electric field, okay, they are deflected towards the positive plate. Now what will come towards positive? Will positive come towards positive? No, they will repel. But yes ma'am, negative can come towards positive plate. That means cathode rays carry cathode ray carries negative charge. I guess this is clear to each and every one of you. Now see. Similarly, when a magnetic field is applied on the cathode rays, now electric and magnetic field, both experiments are done. They are deflected in a direction which shows that they carry a negative charge. They will move in that direction which shows that they carry a negative charge. You can even see from the diagrams over here, one for the electric field, another for the magnetic field. See. This is the electric field that they have applied, okay? This is the electric field. You can see these are the cathode rays. And they are moving towards the, this is positive, this is negative. So it is moving towards the positive. Towards the positive. That means it carries a negative charge. And if I'll talk about the magnetic field over here, they are deflected towards the one which carries a positive charge. They deflected towards that plate. So it hence proves that cathode rays carry a negative charge. Clear everyone? Very good. Moving on to the next part, next property is when cathode rays strike a metal foil, the later becomes hot. This indicates that cathode rays produces which effect, students? Heating effect. You might feel that, ma'am, this is so theoretical. See, this is initial start of our chapter, that is introduction. So it is theoretical, but yes, in the upcoming topics, you will feel that, oh, this is such an interesting topics. See, this is why I'm explaining you, because you should at least know from where electron, protons and neutrons came, right? Now the next is they cause ionization of the gas through their pass. That means they are going to ionize them, dissociate them into its ions, right? They produce X-rays when they strike against the surface of hard metals like tungsten, molybdenum, phosphorescent, okay, each and every substances like this. Now, they affect photographic plates. Next is, they possess penetrating effect. Now, what is penetrating effect? When you can move from one phase to the another phase, okay, that is penetrating, okay. Now, that is, they can easily pass through the thin foils of metals. They are only stopped by the metal foils of greater thickness, which has a larger thickness. Clear everyone? So these were the properties. Now comes charge to mass ratio. See, now we got to know about cathode, okay, that cathode carries a negative charge. These are the properties of cathode. But let us understand about charge to mass ratio. What do you feel? What is charge to mass ratio? See, now over here they have told you the very first thing about specific charge. The charge to mass ratio is referred to as specific charge, and J.J. Thompson basically argued that amount of deviation of the particles from their path in the presence of electric and magnetic field will depend upon three factors. The very first factor is magnitude of the negative charge on the particle. The next is mass of the particle, and the next is strength of the magnetic field. Okay, students. So what happens? Charge to mass ratio was found out. And we observed that it remained same when different electrons and different gases were taken. Okay. Now students, you can clearly see from this particular diagram about the experiment. See now, basically what are we going to see? We are going to see the deviation. So when electric field is applied or magnetic field is applied, we are going to observe the deviation. Okay. When electric field is applied, A is being observed. When magnetic field is applied, our ray will deviate towards the C particle, and when they both are equal in amount, it will strike at B. Okay, now let us understand this in depth, which I have told you. When electric field is applied, deviation from the paths takes place. If only electric field is applied, cathode rays strike at A. See, I told you, if electric field you are applying, it will strike at A. Why? Because cathode is negative charge and it is positive plate, so it will deviate towards positive end. If magnetic field is applied, if magnetic field now only we have seen, so it will go at C. And if they both are equal in number or no field is applied, they will go straight away, that is at B point. Right? Now this is what is written. When electric field is applied, deviation from the paths takes place. If only electric field is applied, cathode rays strike at A. Very simple. Right? If only magnetic field is applied, cathode rays strike at what? C. And in the absence of any field, any field, cathode rays strike at B. That means the straight one. Clear guys? Clear it everyone? Now, by carefully balancing electrical and magnetic field strength, it is possible to bring back the path through which the electron followed, okay, in the absence of electric and magnetic field, and hit the point B. So they are basically saying either they are equal in number, then it will strike B, or if there is no field applied, then also it will go at B. If electric field is applied, it will go at A. If magnetic field is C, it will strike at C. So by doing so, charge by mass ratio was calculated, which remains same for different electrons for different gases. Okay, now students, with the help of charge by mass ratio, the electron basically mass was calculated. Now coming to Millikan oil drop experiment, with the help of this experiment, we calculated the charge on an electron. How we calculated the charge? Basically, in this particular experiment, what have we taken? We have taken an atomizer. Now we are going to spray from the atomizer. We are going to spray the oil droplets from the atomizer. Now we do have two plates over here. One is this plate which has a small hole just as a perforated anode. Okay, just similar to that I'm saying. Okay, now we have this plate which is negatively charged. Now see what happens basically when you are spraying an atomizer. Here you can clearly see X-ray from the source. X-ray basically will provide electrons. So what will happen when you are using the atomizer? Electron will move in, oil droplets will go inside. These are the oil droplets. Now these oil droplets will travel from this hole. Oil droplets will move in the downward direction due to the gravitational force. But what will happen? X-ray will liberate some electrons. Now this is an oil droplet. The electrons are going to surround the oil droplets. And as you can see, it was moving in the downward direction. We have a negative plate at the downward direction. If an oil droplet surrounded with electron goes in the downward direction, we already have a we have a negative plate. Negative will repel. That means repulsive force will occur in the upper direction. So what will happen? It will move in the lower direction and repulsive force is being seen in the upper direction. So both the forces are acting upon it over here, and hence we will calculate the value of charge from this particular example. So see, in the experiment, some fine droplets were allowed to enter through a tiny hole into the upper plate of the electrical condenser. These oil droplets were produced by atomizer. Very simple, I have already told you. The air in the chamber was subjected to the ionization by X-rays. The electrons produced by the ionization, I already told you, of air attach themselves to the oil drops. They will surround it, okay? Thus, oil droplets acquire which charge? A negative charge. It will acquire which charge, students? It will acquire a negative charge. So, by this way, charge on electron was also calculated, which I have already told you in the start. Clear, guys? Now comes the discovery of protons. Discovery of protons, in other words, is a study of anode rays, students. Now, in the previous session, in the previous slide, I have already told you that there are some rays that are traveling from cathode towards anode, that are cathode rays. Now, it is also observed that there are some rays which are traveling from anode towards cathode, that are coming, from anode towards cathode. So, they are anode rays. See. In the previous case, I have taken the Crookes tube over here, cathode over here anode, but I am now reversing both of the concept. Over here, you will take perforated cathode over here. Now, you are going to take perforated cathode. What are you going to do? Perforated cathode. And there are some rays that are coming out from this also. Okay. So, these are cathode rays that were traveling from cathode towards anode. From cathode towards anode. These are traveling. Now, there were some rays which are traveling from the opposite end. I already told you in the previous case, we took cathode over here and anode over here. Now, it's vice versa. Now, these are the cathode rays traveling from cathode towards anode, and there are some more rays. There are some more rays which are traveling from anode towards cathode, which are referred to as your what? Anode rays. And at this ZNS coating, we are going to see it's, the image that it is going to create over there, the glow that it is going to provide over there, which illustrated that there are anode rays also. Now see, students, the properties of anode ray quite simple. They travel in straight lines, same. Okay, because when we are keeping a certain object in their path, they are going to produce its shadow, right? Moreover, their speed is much less than that of the cathode rays. Very important part. Now, they are also made up of material particles. They are going to rotate the wheel just as the cathode rays have done. Now, they are positively charged. See, cathode rays were negatively charged, they are positively charged. That's why it is the study of or discovery of protons. Clear? Now, as it is indicated by the direction of deflection of these rays in electric and magnetic field. See, cathode rays were deflecting towards the positive end. Anode rays will deflect towards the which end? Towards the negative end. If it is deflecting towards negative, then it means it is positive in nature. Now, unlike cathode ray, the ratio charge by mass is found to be different for the particles constituting anode rays. When different gases are taken, see, I already told you, the charge by mass ratio in the case of electrons were same throughout. If you are taking different electrons, if you are taking different gases, but over here it is different. Charge by mass ratio is different. Clear, everyone? Now, students, the next property they are telling you about, the value of the charge on the particles constituting the anode ray is found to be dependent upon the nature of gas that you are taking inside the discharge tube. Okay, and moreover, it depends upon the number of electrons that are knocked out. The mass of the particles constituting the order is also found to be different for different gases because charge by mass ratio is different. So yes, that is also the different value. These are the properties that you should know. Now comes the discovery of neutron. Now see, neutron, students, you very well know, has no charge. It is neutral in nature. It has no charge. But yes, its mass is equal to the mass of hydrogen atom. So now see, how is neutron discovered? So basically, when you are going to bombard an alpha particle on the beryllium. Now, helium basically is an alpha particle. So you are bombarding an alpha particle on the beryllium. You are going to obtain what? You are going to obtain neutron, and carbon is released. Now, what is this 9 and 4 over here? See, always remember, an atom is represented as X, and this over here we have A and here we have Z. Z basically represents your atomic number and A represents your mass number or atomic mass. Clear, guys? Mass number or atomic mass. So I guess now everyone knows here 9 is mass number, 4 is atomic number, 4 is mass number and 2 is atomic number. Similarly, 12 is mass number or mass and 6 is atomic number. So here we got what? We got a neutron. Neutron has mass of 1, basically mass number 1. But yes, see, now you will say neutron is 1, 0. How it came out to be? Very simple. See, 9 plus 4 is 13. So you need to balance it. It is 12 plus 1 is 13. Now 4 plus 2 is 6. 6 it already has. So here 0 will come. Here 0 will come. Okay, in case of neutron, electron, proton, we don't write atomic numbers and all that stuff. Okay, we only use it as for representation. Okay, guys, electron has a negative charge, proton has a positive charge, neutron has no charge on it. Clear, guys? So don't consider it as atomic number, as mass number. Basically, this is just to balance the equation. Okay, now neutron is chargeless particle and have a mass equal to that of proton. Okay, its mass is equal to that of what, man? Proton. Now coming back to the next concept, we have atomic models, and starting with the very first atomic model, we have Thompson model of atom. Now what do you think? What is Thompson model of atom? Thompson model of atom has told us, till now we have understood about atom. Atom is made up of electron, protons and neutrons. But what about the arrangement of electron, protons and neutrons in the atom? So first scientist came, and he was Thompson. So basically Thompson told that it is that basically, if I am describing an atom, atom is just similar to the watermelon. Just as the positive part is there in the case of atom, it is seen in watermelon that all the red part is the positive one, and the seeds, basically seeds of watermelon, represents the electrons that are embedded into it. So this was the representation which Thompson did. So Thompson told that the positive charge is distributed like fibrous material of a watermelon, that electrons are just like seeds in the watermelon, and the red part is the positive charge that is distributed all around. So this was the key concept that Thompson told, that he compared it to watermelon. So here you can clearly see this is the positive charge and electrons basically is the seed. So he's comparing the atomic model with the watermelon. Okay, but yes, there were some limitations due to which it failed. Okay, let me tell you how it failed and what are the key concepts and which was the scientist which came into account and explained him perfectly. So now, the next atomic model that came was Rutherford model of atom. When Rutherford model of atom came, what he did, he took a radioactive source. And after taking a radioactive source, he bombarded at the rays of alpha particles from that. What he saw that there were deviation observed at different angles. What was the deviation? Let us understand them. He told that, for example, if we have an atom, okay, and when he bombarded something, so what he observed, that some of the rays were traveling straight. Some of the rays were traveling straight and some were deflecting at a certain angle or deviating at a certain angle. While students, very few were coming back. Very few were coming back. So this was seen in the case of Rutherford model of atom. Let us see that what conclusions he made. See, when he said that, 99.9% rays are traveling straight. They are traveling straight. That means it contains some mass in this. It has some mass. This was the observation. The second observation, see, if I have told you that they are deflecting at a certain angle, that means the centermost thing contains a positive or a negative charge due to which the deflection is occurring. Third part, at the center it is reflecting back. That means there is something heavy at the center. So three observations were made. Firstly, it has a lot of space. Secondly, there is a positively charged species due to which it is showing deflection. Third, it is reflecting back because there is something heavy at the center. Okay, students. So these were the observation made, due to which, according to Rutherford model of atom consists of two parts. One is nucleus and another one is extra nuclear part. Now, according to him, nucleus contains neutrons and protons. And due to that, nucleus is positively charged species. And due to this, nucleus is positively charged species. Now, what happens in extra nuclear part? That electrons revolves around the nucleus in the extra nuclear part. Clear, guys? So this was the observation that was made through the Rutherford model of atom. But what were the drawbacks of that model? It failed to explain the atomic spectra or the line spectra. It fails to explain the stability of an atom. So these were the drawbacks. Now come, students, atomic number and mass number. Let us understand about them. How do we represent a particular element? See, already told you, X basically, if it is your element, then here you are going to write Z, here you are going to write A. So Z basically is your atomic number. Also, it is referred to as number of protons. Okay. And A basically is your mass number or atomic mass. And students, A is equal to protons plus neutrons. Z is equal to number of protons. Also write one more thing. Also, for a neutral species, number of protons is equal to number of electrons. That means it is equal to atomic number, right? Everybody write it down so that we can start with our terms like isotones, isotopes, isobars, isotones, all of that stuff. Everybody please write it down. So students, now we very well know about how to calculate number of neutrons, protons, electrons from the given representation. Now it's time to understand about, it's time to understand about isotones, isoelectronics, isostars. Okay, so first of all, let us understand the very first topic of ours, that is isotones. What are isotones? What are isobars? Okay, so see, isotones, isobars, then we have isoelectronics or isoelectrons, and then we have isostars, we have isotopes. First of all, let us understand about isotopes, everybody. What are isotopes? See, the one that have same atomic number but different atomic mass. Mass number you can write or atomic mass. It's up to you. Yes, everyone. Now let us talk about isobars. Just the opposite. Same mass number but different atomic number. Talking about isoelectronics or isoelectrons, it has same number of electrons. Students, first of all, write all of these three over here so that we can now move on to the next part as well. Everybody please write down. Yes. Done. Now comes isotones. Isotones means same number of neutrons. What do you refer to as isostars? See, isostars is also the same number of electrons but also the structure. See here, isoelectronics or isoelectrons the same number of electrons, but over there we are recommending as structures also. So it is one of the same things. You need not to write it all over again. If it is written isostar also, students, do remember it is same number of electrons as well as the structure. Clear everyone? Everybody please write it down so that I can move on to the next slide if it is done. Yes. And one more thing, here we have isodiaphers. See, isodiaphers is not in your syllabus, but let me tell you, it is basically the same number of difference in neutrons and protons. That is isodiaphers. But for your knowledge sake, if you want to write, you can write it as well over here, right? Now, students, moving on to the next part, we have wave nature of electromagnetic radiation. Do remember, we do have wave nature and a particle nature. See, we are talking about wave nature, then this is how a wave looks like. This is basically the amplitude. What is an amplitude? The height, okay, of the crust or the trough, okay, and this is the crust, this is the trough, right? What is this lambda? Lambda is basically the wavelength. So what is wavelength? Wavelength is the distance between two consecutive crust or two consecutive trough, right? You very well know from the lower classes, you may have heard about it. So first of all, let us understand about electromagnetic radiation before starting the wave nature of electromagnetic radiation. So it is the energy transmitted from one body to the another body in the form of a wave. Through the wave, you know, energy is being transmitted and it travels in space with some same speed as the speed of light, students, and these waves are referred to as electromagnetic waves, right? So let us understand about them in detail. See, this is again the spectra that you are going to see. Now see over here, students, this is the value of wavelength and this is the value of a frequency, students. This is the value of wavelength, this is the value of frequency, and these are your spectrum. These are your gamma rays, then your X-rays, UV rays, visible spectra, IR spectra, microwave, FM radio waves, then we have long radio wave spectra. Okay, you need not to learn the values, just remember if the frequency is increasing, if the wavelength is increasing, frequency is decreasing, because they both are inversely proportional to each other. Now, this order you have to learn because it's really very important, students. This is really very important. Everybody, you need to learn this order. What it is basically, electromagnetic spectrum. The different types of electromagnetic radiations differ only in their wavelength and hence frequency. Wavelength and frequency both are inversely proportional. If the frequency is increasing, wavelength is going to decrease. They are going to ask you again and again the order. So the wavelength increases in the following order. If this is the order of wavelength, frequency order will be opposite of this, right? So always remember this order. You need to learn it. It is cosmic rays, gamma rays, X-rays, UV rays, visible, infrared, micro, and then the radio waves. Clear? Everybody please write it down. Everybody write it down so that now we can learn in depth about the wave. Everybody please write it down. Done, students? Okay, now comes the main characteristics of a wave. The main characteristics of a wave. Let us start with wavelength. See, wavelength basically, what do you refer to as wavelength? The distance between two consecutive crust or trough. That is what is wavelength, represented by lambda. Represented by lambda, everybody. Write down the definition for wavelength, everybody, and then we are going to write the next definition of ours. Now comes frequency. What is frequency? Number of waves passing through a given point, okay, is referred to as your frequency. Number of waves passing through a given point at a given interval of time. Also write it, at a given interval of time. Frequency is represented as like this. Right, everyone? Right, everyone? Now comes what, ma'am? Now comes your velocity. Also write it down. V is equals to C by lambda. Relationship between frequency and wavelength. If wavelength increases, frequency is going to decrease. C is speed of light. Also write down this formula, students. Now talking about the next one, we have velocity. What is the formula velocity? You may have done in your physics, distance upon time. So basically distance traveled by one wave in particular interval of time. Clear, guys? Now comes wave number. Very simple. Wave number. Number of waves passed at a certain interval of time. Wave number is 1 by frequency, students. Wave number is 1 by frequency. Okay. Amplitude. Amplitude basically is height of crust or trough. So write down the characteristics of waves so that we can move on to the next topic of ours. Everybody please write it down. Done. Now comes particle nature of electromagnetic radiation, and the very first that we are going to start with is black body radiation. We are going to start with black body radiation. Now what happens when we are heating a certain body? It will radiate the thermal energies with different frequencies and different wavelengths, okay? So basically a body is capable of absorbing all types of radiation and emits completely the absorbed radiations. So basically it will emit thermal radiations with different wavelengths and different frequency when you're going to heat a black body. So this is black body radiations, which explain us about the particle nature of light. One more theory came into account, that is Planck's quantum theory. According to Planck's quantum theory, what do we understand? We understand that yes, see what is over here, the word that you can see, according to this theory, energy cannot be absorbed or released continuously. So what happens? If it cannot release continuously or absorb continuously, it will do so in the small form of small packets, which are referred to as quanta. Okay, so see, according to this theory, energy cannot be absorbed or released continuously, but it is emitted or released in the form of small packets called quanta. In the case of light, quanta basically, students, is referred to as photon. Photon is basically the quanta. Okay, so energy will be transferred in the form of small packets referred to as quanta. The photon travels with the speed of light. Energy is basically, you can see the energy is directly proportional to what? Directly proportional to frequency. E is equals to h nu. And you very well know nu is C by lambda. So you can say E is equals to hc by lambda. Many questions are asked from this particular formula. They can give you that we have two lights with different wavelengths. Calculate the relationship between both of the frequencies. So you can say E1 is equals to hc by lambda 1. E2 is equals to hc by lambda 2, and you can compare both of them, divide both of them, find the relationship. Here Planck's constant h value is also given to you, 6.62 into 10 raised to the power minus 34. Again repeating, these two formulas are really very important, from which questions they generally ask you. Now comes photoelectric effect. What do you refer to as photoelectric effect? Basically you are bombarding a beam of light on a particular metal surface, okay, and electrons are emitted from that metal surface. Okay, so this is what is happening. See, you are bombarding a certain beam of light at a metal surface and electrons are emitted out. Okay, what happens over here? Electrons are emitted out. This is what is photoelectric effect. Now see, students, if I'll talk about photoelectric effect here, this formula is really very important. E is equals to W plus kinetic energy. E we basically know is h nu, and W over here is our threshold that we talk about, the work potential. Okay, so it is h nu naught plus kinetic energy. In the question papers, this formula will help you to solve a lot of questions based upon the work potential. Everybody please write it down. Everybody please write it down. This formula is very, very, very important. Even you can write it, it is work function or threshold energy. They will provide you this value, they give you this value, they will ask you the value of work function. They will ask you the value of work function. Again, repeating, you are bombarding a beam of light at a metal surface and it is liberating some electrons. And then with the help of detector, you are detecting it. Okay, so the smallest particle of energy is photon over here. Okay, right, students? Now, the minimum potential applied by which velocity of ejected electron becomes zero is referred to as stopping potential. You see, in order to stop this process, because electrons will start to liberate out, there is stopping potential. That minimum potential you will apply so that electrons won't get emitted. And that is basically stopping potential is equals to this. Clear, students? Now, moving on to the most important topic of our today's session, that is Bohr's model. What is the postulates of Bohr model of atom? So, the very first postulate is atom is of spherical shape having the size of this particular order. The thing is, it is spherical in shape. Second postulate, whole mass is concentrated in the center called nucleus. As you have seen in the Rutherford model of atom, at the center is heavy. So, whole mass is concentrated at the center. Next, electron revolves around the nucleus on only a limited circular path. Electrons will revolve around it only in a limited circular path. Assume that electron does not radiate energy during its evolution. It won't radiate, it will revolve around circular path, that is shells basically, that you will get to know, okay. Now, only those orbits are allowed whose orbital angular momentum is integral multiple of h by 2 pi. So, this formula is yet again very most important. MVR is equals to NH by 2 pi. Okay, that is the formula of angular momentum that you should know, orbital angular momentum. When electron absorb energy, it jumps to a higher orbit, and when it comes back, it radiates energy. See, for example, this is ground level, this is higher energy level. When electron is moving from here to here, okay, and coming back from higher to lower energy level, it will radiate some kind of energy. So, this is what is written over here. When electron absorbs energy, it jumps to higher orbit, and when it's come back, it radiates energy. This postulate will explain us about spectra. Now, these formulas I have written all over here. As you all know, it is ultimate recap session. So, all the formulas are required for you. There is no derivation section that we have to do over here because it is quick recap. So, you have to revise it and apply on the questions. So, the very first formula is with regard to the radii. They can compare, they can give you two, atoms, and they can ask you relationship between both of the radii. So, you can take R1, N1, Z1 and write R2 also similar, and you can divide it and solve it. So, this is the formula of radius, that is 0.0529 n square by Z Armstrong. Then this is the velocity of moving electron formula. Then it is potential energy formula, and then C, we know potential energy is the twice of the total energy. So, basically no need to learn this formula. Let me tell you which formula you have to learn. You have to learn these three formulas. And among these three, let me tell you, this formula is mostly used in all of the questions. Clear, guys? Everybody, first of all, write the previous formulas, and then I will be proceeding to the next formulas. Write down the previous formulas, and I will be proceeding to the next formulas. Done. Now, see, students, here we have spectral lines of hydrogen spectrum. Everybody written this? Okay. Now, we have spectral lines of hydrogen spectrum. See. So, you very well know this is first ground level, n is equals to 1, n is equals to 2, 3, 4, 5, 6. See, if all the electrons are coming back to n is equals to 1, that will be Lyman series. That means from C, n is equals to 8 to 1, n is equals to 7 to 1, n is equals to 6 to 1, 5 to 1, 4 to 1, 3 to 1, 2 to 1. So, if it is coming back to the first level, it is Lyman series. If it is coming to second level, n is equals to 2, it is Balmer series. If it is coming to n is equals to 3, it is Paschen. If it is coming to 4, it is bracket. If it is coming to 5, it is P1. And C, if it is coming n is equals to C. At 1, it is your Lyman. At 2, it is your Balmer. At 3, Paschen. 4, bracket. 5, P1. And 6, Humphrey. So, by this way, it goes. Right, students? Now, questions can be asked upon these formula. The number of possible line produced when electron jump from nth to first orbit. This is the formula. The value of nth orbital you will put over here. You will get number of possible lines that are produced. Next, possible line produced when electron jumps from n2 to n1. So, this is the formula for that case. Everybody write it down. Now, students, moving to Heisenberg's uncertainty principle. Yes, Heisenberg uncertainty principle. Yes, students, what do you refer to as Heisenberg uncertainty principle? When it is impossible to explain, the position and the momentum altogether, the change in position and the change in momentum altogether, then Heisenberg uncertainty principle was introduced over here, students. Let us understand about the Heisenberg uncertainty principle. This is change in position and this is change in your momentum. It is more or equal to h by 4 pi. This is the formula for Heisenberg uncertainty principle. Heisenberg uncertainty principle. Yes, students. When it is impossible to determine the exact position and the momentum, then Heisenberg uncertainty principle was introduced. Here delta x represents change in position, delta p represents change in momentum. So one more formula you can obtain, delta x into m delta v h by 4 pi. This is also one more formula with regard to Heisenberg uncertainty principle. Everybody please write it down. One more thing you may observe that this m basically, here no delta will come. So one more formula you can obtain is take this m onto the other side. Previously a year asked question was asked upon this. Delta x into delta v is more or equal to h by 4 pi m. Okay students, clear? Now comes nodes and antinodes. What do you refer to as nodes? Anybody any idea? What do you refer to as nodes? See, what do you refer to as nodes? These are types of nodes that you have written over here, radial node and the next one is angular node. But what exactly is nodes, or I would say nodal plane? See, nodal plane is that plane where the probability of finding electron is 0 first of all. There is no probability of finding electron. But ma'am, what is node? If nodal plane is something where probability of finding electron is 0, node is where the probability of finding electron is minimum. See, so nodes are basically categorized into radial nodes and angular nodes. The formula to calculate radial node is n minus L minus 1 and angular node is L. So if I'll ask you the value of total nodes, it will be n minus L minus 1 plus L. This will be n minus 1. So by this way you can calculate the total nodes. What is radial nodes? It represents a sphere at some distance from nucleus where probability of finding electron is 0. Okay. Now what is angular node? It represents a plane passing through an orbital where probability of finding electron is 0. So where probability of finding electron is minimum, that is basically your nodes, students. That is basically your nodes. Talking about shapes of orbital, students, it is very simple. If I'll talk about s orbital, it is spherical in shape. Yes, if I talk about p orbitals are basically dumbbell in shape. This is for example py. If I'll talk about px over here, and if I'll talk about pz, let us talk about the d orbitals. So d orbitals, we have dxy, dyz, dzx, dx square y square, dz square. So first of all, let us draw dx square y square. See, dx square y square are basically like this, which are present on the axis. If it is x-axis, y-axis, these are double in shapes. This is dx square y square, which are present on the axis. Let us draw dz square over here. This is the structure of dz square. Okay. This is the structure of dz square, which is quite different, but yes, over here also lobes are present on the axis. Let us draw now the x square, dxy. This is x and y. Here lobes are present in between the axis, students. Let us draw dyz. If it is y, it is z. Let us draw dxz. If it is x, it is z. These are present in between the axes. Dx square, y square and dz square are present on the axis. Okay, students? Now coming to quantum numbers, there are 4 types of quantum numbers that we study: principal quantum number, azimuthal quantum number, magnetic quantum number and spin quantum number. Let us start with the very first one, that is principal quantum number, represented as small n, students. It is represented as what? Small n, ma'am. Right? So it represents name, size and energy of shell to which an electron belongs. It will tell you about shell. N basically tells you about shell. To which shell does it belongs? For example, if it is our nucleus, this is 1 shell, second shell, third shell, fourth shell. So here n is 1, here n value is 2, here n value is 3, here n value is 4. N value is 1, that is K shell, L shell, M shell and N shell. So L represents shell, that is principal quantum number. Okay, now N represents shell. It represents name, size and energy of the shell to which the electron belong. Greater the value of N, greater is the energy of shell. Always remember. Next, this is very, very important. The number of electrons in a particular shell is equal to 2n square. 2n square. Put the value of N in first. What you will get? When N is equals to 1, how many electrons? 2. When N is equals to 2, how many electrons? 2 into 4, that is 8. When N is equals to 3, what is the value? 18. Yes. When N is equals to 4, how many electrons? 32. So by this way you can find the number of electrons in each and every shell. Moving on to the next one, we have azimuthal quantum number. What do we have, ma'am? Azimuthal quantum number represented as L. And it represents the shape of subshell and the orbital. It is used for calculating orbital angular momentum. Always remember it. And one more formula. The number of electrons in a particular subshell is equal to 2L plus 1. Clear? Number of electrons in a particular subshell, because it tells about subshell. Principal quantum number will tell you about shell. It will tell you about subshell. Now see. L for S is going to be 0, for P is going to be 1, for D is going to be 2, for F is going to be 3. Always remember. And how do you calculate the value of L? L basically is what? 0 to N minus 1. Is it right or is it wrong? Very simple formula, students, you have to go. You have to do the very simple formulas in order to calculate the value. Yes, students, everybody please write it down, the principal quantum numbers. Yes, everybody written. Shall we move on to the third type? Okay. Do remember L is equals to 0 to N minus 1. This is the formula. If you know the value of N, you can find the value of L. Okay, and L for S is 0, P for 1 is for 1 it is P, and for D it is 2, for F it is 3. Coming to the third type, it is magnetic quantum number represented as small m. Now, it represents the orientation of the electron cloud, students. How do you calculate the m? M is basically minus L2 plus L. Minus L2 plus L. Very simple. Minus L2 plus L. Minus L2 plus L. Clear, everyone? M is basically minus L2 plus L. Always remember this. See, if L value is 0, M is going to be 0. Right? If L value is 1, M is going to be minus 1 to plus 1. That means it is minus 1, 0 and 1. Right? Now, if L is 2, M value will be what? Minus 2 to plus 2. That means minus 2, minus 1, 0, plus 1, plus 2. That means the 5 orbitals of the D. Here 3 values, so this is 3 orbitals of the P. Here it is 1 value, so it is S orbital. Right? Clear, everyone? Clear, everyone? Now comes the next part, that is spin quantum number, which tells us about the spin, that is represented by small s. It tells about the spin around its own axis. Okay, how electron revolves. Electron spin, it either can be plus half or it either can be minus half. Plus half represents the clockwise direction spin and minus half represents in the anti-clockwise direction. Very easy. Now, students, what are the rules for writing electronic configuration? So, the very first rule is of Bohr principle. Of Bohr principle depends upon the N plus L rule. More the value of N plus L, more will be the energy. If N plus L value is same, more value of N, more will be energy. So now, students, your today's homework, very first homework, you have to write the order for filling electrons. No need to worry. In the third chapter also, that is our classification of elements, I am going to tell you about the electronic configuration, though I am giving you an example how you have to tell. See, you have to write the order. I am telling you how you can find the order. See, first comes 1s, then comes 2s, then is 3s. Okay, I am just taking a random example. 2p, 3p, okay, 4s. See, for example, if we have these over here. Now, what is the value of n? N over here is 1. This is n value. S is written over here. S. For S, L is going to be 0. So n plus L comes out to be what? Ma'am, here it comes out to be 1. For this case, n is 2. What is S? What is L for S? 0. So it comes out to be 2. 3S. 3 plus 0, it comes out to be 3. Now for this 2 is n. What is L for P? It is 1. This comes out to be 3. Now for this 3P, it is 3. What is the value of L for P? See, L is 0 for S, 1 for P, 2 for D, 3 for F. Right? For P, it is 1. This comes out to be 4. Now for this 4 plus 0, 4. See, the lowest value is of 1s, so it will have least energy. Then we have what? We have 2 value, that is 2s. After this, we have what? We have 3s and 2p. So I already told you the less value of n will have lesser energy, more value of n will have more energy. So now will come 2p, then will come 3s, and then now between you can see then we have 3p over here with the value of 4 and 4s. So lesser value of n is 3. So 3p will come, then 4s. So this is the way how you fill electrons. First you will fill electrons in 1s, then in 2s, then in 2p, then in 3s, then in 3p, then in 4s. So you have to write the complete order till 7s. In the chat section, you have to write your name and the order by yourself by following this rule, students. Clear? Now students, comes the next rule for writing electronic configuration is Pauli exclusive principle. Also one more thing, always remember, see, in S orbital maximum 2 electrons can be seen, in P orbital maximum 6 electrons can be seen, in D orbital maximum 10 electrons, and in F orbital 14 electrons. Because see, S is basically containing 1 orbital, so 2 electrons like this. In P, I told you 6 electrons, so 1, 2, 3, 4, 5 and 6. Similarly, in D, 5 orbitals are there, so 1 orbital contains 2 electrons, so 10. In F, 7 orbitals are there, so 14 electrons. Now, according to Pauli exclusive principle, in an atom, no 2 electrons have same value of the 4 quantum numbers. Why? Because their spin will be different. You will always see one will have plus half, another one will have minus half. So see, in the same orbital, electron can accommodate in opposite spins. They will have opposite spin. So this is what is Pauli exclusive principle. Application of this principle is determination of maximum capacity of electrons in an orbital and orbit. Now conclusions, these formulas are very important. The maximum capacity of an electron in an orbit is 2n square, already done. The maximum capacity of electron in type of orbital is 2, 2l plus 1. This also I have already told you to write down. Now, an orbital can have maximum of 2 electrons with opposite spin. This is explained by Pauli exclusive principle. Now comes the last one, that is, students, basically Hund's rule of maximum multiplicity. Hund's rules of maximum multiplicity explains you that whensoever you are writing any configuration, let us consider about carbon. It is 6, atomic number is 6, so it is 1s2, 2s2, now 2p, 2 basically, right? Similarly, if you are going to write it, 1, 2 electron in S, 2 electron in S. Now in P, you have to show 2 electrons, so it is 1 and 2. You have to write it like this. You cannot write in P like this, 1 and 2. This is wrong way. 1 electron should be filled in each and every orbital. Let us consider for nitrogen, atomic number is 7, 1s2, 2s2, 2p, 3. So see, it should be like this, 2 electrons, then 2 electrons. In P, we have 3 orbitals. So 1, 2 and 3. Don't put 2 first and 1 first. 1 orbital will get 1 electron each first, and then it will be filled. So see, according to this rule, electrons are distributed among the orbital of a subshell in such a way so to give maximum number of unpaired electrons with a parallel spin. Now this also question is generally asked, spin multiplicity, that is 2s plus 1. Now S is basically the magnitude of the sum of the total spin quantum numbers of the electrons that are present over here. Now fully filled orbitals are almost more stable due to spherical symmetrical. Therefore half filled orbitals are more stable than the other configuration due to maximum spin multiplicity. Always remember, fully filled are more stable, then is half filled, and at last is partially filled. Partially is when 1 electron. Half filled is each orbital having 1 electron. 1 electron. And fully they are completely filled. No space for any electron. Now students, these were the rules. There are some exceptions to write the electronic configuration. But yes, before that, let us write the electronic configuration of hydrogen. It is going to be 1s1. Now of hydrogen, helium, it's 2. So it is 1s2. See how I am filling. S will have maximum 2 electrons. Now comes lithium with atomic number 3. So it is 1s2, 2s1. 2 electrons in S are already filled, so it will move on to the next one. Now, helium, lithium, beryllium. Atomic number 4, it is 1s2, 2s2. You will say, ma'am, how you know after 1s, 2s will come? According to Aufbau principle, I already told you to write it. Right? Now, see students, hydrogen, helium, beryllium, boron. Atomic number 5, 1s2, 2s2, 2p1. Now, carbon, nitrogen already told you. Oxygen, let us write 8. It's 1s2, 2s2, 2p4 basically, right? Let us write of sodium, atomic number 11. So it is 1s2, 2s2, 2p6, 3s1. Let us write of magnesium. It is going to be what? 1s2, 2s2, 2p6, 3s2. So this, how I know after 2s, 2p will come? According to Bohr principle, according to n plus L rule. Now students, come the exception part. There is an exception in atomic number, that is chromium with 24 atomic number. Okay, I'm going to write for chromium, and atomic number 29 is your homework. You have to write its electronic configuration in the chat section, guys. I'm writing of chromium. Now see, it should be 1s2, 2s2, 2p6, 3s2. Now see, 2 to 4, 6, 10, 10 and 12. Now, 3p6, how many? Just you need to count the electron, students. That's it. What you need to do over here is you need to count the number of electrons that are provided to you. So I'm just counting. It is 1s2, 2s2, 2p6. That means how many? 4 plus 6, 10, 12. And then we have is 6, 18 electrons. How many are we still left with? We are still left with now 4s2, 4, 10, 12, 18, 18 and 2 is 20. 4 are left. 4 are left. So it is 3d4, but it is wrong, students. It is wrong. Why? Why, ma'am? It should, if there is an exception, what will happen? It will be 1s2, 2s2, 2p6, 3s2, 3p6, 4s1, 3d5. This is going to be the state. This is going to be the state, students. It will be 3d5, 4s1, 3d5. Why? Because see, if I am writing 3d4 over here, 3, 4. It is not, it is partially filled. But if I am writing 3d5, 1, 2, 3, 4, 5. Each orbital is having at least 1 electron. Now only I told you fully filled is more stable, then partially, and at last is fully filled, then half filled, then partially. So this is half filled, that means it is quite stable in this configuration. So there is an exception. 1 electron from the s orbital over here will transform into this d orbital, and this is going to be the configuration. Similarly, you have to write for atomic number 29 in the chat section, students. Clear, everyone? So now students, this ends our today's session over here. We have completed the whole chapter, structure of atom, in this one short session of ultimate recap for your achievers batch. I hope so you have completed all the topics one by one. Now it's your turn to prepare your notes, and it's your turn to practice a lot of questions. Now we shall be meeting in the next lecture with the next chapter, that is classification of elements. Till then, keep smiling, keep learning. Thank you so much, my dear students, and have a good day.